all the equations that can be created and or used for the following circuit. And they want you to talk about KCL, or Kirchhoff's current law, Kirchhoff's voltage law, and Ohm's law. So it's just getting you to think about how you're going to solve some of these circuits using the rules that we've discovered. So let's just talk about the physics. At least that way we can start to organize our equations, and then when we get actual numbers and questions to come, we'll know how to proceed. So first of all, we look at this circuit and we see the positive terminal of the battery, and we know that leaving the battery is always our total current, which they're calling I0. Now the total current reaches this point C here, a junction, where it splits up into three different parallel paths. I1 through R1, I2 goes through R2, and I3 goes through R3. And then it all joins up again, you can see by the arrows, at point D. So we call those 2 points nodes. So first of all, if we look at Kirchhoff's current law, current coming in equals current coming out, I0, the total current coming in, gets split up into I1 plus I2 plus I3. And then it leaves again and becomes I0. Now what about the voltage law? I'll do that in blue. Now the voltage law, I like to use the loop rule, Kirchhoff's voltage law. And it says around any given path or any given loop that goes from the positive terminal to the negative terminal of the battery, all the voltages must add up to the total. So if I follow this current through resistor 1, there's one possible path all the way back to the negative terminal in the battery. There's only one resistor in that loop. So that one resistor is across the entire battery, in other words. So R1 will get the full voltage, which we're calling AB, VAB. So VAB will be equivalent to voltage across R1. Now you can imagine I could do the next loop through R2 and the next loop through R3, outside, inside loops, and it's going to give me the same result. V1 will be equal to V2, will be equal to V3, which makes sense because I've been saying all along that the voltage across parallel legs should be the same. So my total voltage is the same as V1, same as V2, same as V3. Now what about Ohm's law? Well, Ohm's law is simply an equation that says my voltage is current times resistance. So I can apply this formula at any spot on this diagram as long as I'm consistent. So for example, let's talk about our total voltage. Our total voltage, which they're calling AB, will be equivalent to the total current times the total resistance. Now if I look at this circuit, it's a parallel set of resistors. So I can easily calculate my total resistance. So 1 over R0 will be 1 over R1 plus 1 over R2 plus 1 over R3. So if I can get my total resistance using my parallel resistance formula, and I know VAB, I can get my total current. Now we can also focus in on the individual resistors. If I want to find the voltage across R1, for example, a voltage meter across R1, I'm going to get the following. V1 is I1 times R1. So if I know the value of R1 and I know what V1 is, and don't forget, we already know that V1 is the same as my total voltage, then I can figure out the current through R1. And you can imagine I can do that for every single resistor. All those voltages, R2, R3, are all VAB, so I can write VAB is also equal to I2 times R2. VAB is also equivalent to I3 times R3, etc.